Hi, I'm Kian, and today I want to show you how to solve this integral, the integral from 0 to infinity of 1 over e to the power of x plus 1. For making this integral a little bit easier, I'm going to multiply the numerator and denominator by e to the power of negative x. So actually, I get the integral from 0 to infinity, and then at the numerator, I have just e to the power of negative x. And then at the denominator, e to the power of negative x times e to the x is just 1. And then plus e to the power of negative x. Now I'm going to use a u substitution. I'm going to let u to be equal to the denominator, which is 1 plus e to the negative x. And by definition, I know that when taking the derivative of both sides, we know that du is just e to the power of negative x, but don't forget the chain rule, which will multiply by the derivative of negative x, so we get negative e to the power of negative x. And now we can see that e to the power of negative x is also included in the numerator of this integral. So there's some simplification actually when we turn this integral to the u variable. And now, so when we simplify this integral, actually I'm going to use a different color, we will get the integral, but because this is a definite integral, we should also change the boundaries. So as x is equal to 0, we know that 0 e to the power of 0 is just 1, 1 plus 1 is 2, and then as it is infinity, e to the negative infinity is a 0, 0 plus 1 is 1. And we have negative 1 over u, so I'm going to include negative, and then 1 over u du. And the reason I put the negative outside of the integral is that I want to use the negative to actually interchange the boundaries of the integral. So this is actually the same as the integral from 1 to 2 of natural log of, sorry, not natural log, actually 1 over u. And then when taking the integral of 1 over u, we get natural log of absolute value of u. And then we should evaluate this from 1 to 2. So we get natural log of 2, and then minus natural log of 1, which is 0. So we get actually natural log of 2 as our answer. Thanks for watching. Please subscribe to my channel and watch previous videos.